and we're live with our 121st episode of Absolute AppSec. I'm Ken Johnson at CK Tricky on Twitter, joined by my lovely co-host Seth Law at Seth Law on Twitter. Seth, say hi.
Hey, everybody. Welcome back to another episode. We are super excited to have Logi Kill back with us. Stefan is a good friend. He's been on the podcast multiple times. He's even helped me or helped us co-host at some point, right? It's been a little while, but whatever. Yeah. we always have something fun to talk about when Logi comes on. We don't really have a lot of announcements at this point. I did want to bring up and promote CactusCon again. It's going on in just a couple of days here. Go to cactuscon.com to check out the lineup. It's all virtual this year. Andrew and the team decided, again with COVID, like everybody else, to go virtual. But there's a couple of good days of really technical talks that you should check out. And then you should go next year when it's actually in person. Outside of that, what else was I thinking of? Oh, next week we're going to have Brian Glass, Professor Glass, on to talk OWASP Top 10 after the discussion that Ken and I had last week on the WallArm blog post. Brian reached out, and it's actually like the blog post itself. I did want to address this a little bit, Ken, before we moved on and jumped onto some of that with Logi. You and I, when we were looking at that blog post, thought it was coming from one of the organizers of the Top 10 project at OWASP, and it wasn't, right? It was actually analysis that was done by WallArm on what they thought the Top 10 should be coming up. So it should be an interesting discussion with Brian as he helps lead up the data gathering for the OWASP Top 10, and they have lots of discussions, and he has lots of opinions about it as well, which is good. So that'll be next week. I think that's everything from me. I mean, unless Logi, you want to jump in onto the top 10 and how it's an awareness doc and not like an actual like statistical analysis. But
well, so interestingly, most people don't know, but Brian and I have been involved with OWASP Top 10 since like 2013. And I helped with 2013. I helped Brian crunch the stuff for 2017, just like as a sounding board. Brian did a lot of the work, and he's an absolute unsung hero for the work that he's done for OWASP. But it's been interesting to see, like, yes, it's not a statistical sounding board. It's not, it's more statistically driven rather than like pure statistics. Obviously, it's not a DBER. It's not something like that because it's an aggregate. There's no ontology. There's no like direct list of things that people are putting together. But Brian really has brought a lot of professionalism and a lot of analysis to it. Versus when we were first getting involved and Brian was first working on stuff and I was first being a jerk about it. It was very much like Dave Wickers and a few people like sort of pulled together some stuff and it looked good and it worked well. And, we could teach classes off of it and that was it, whereas Brian was really taking it far from there. So, yeah.
And that was it. Like we were all kind of involved at some point on the 2017 one when he really stepped in and actually did data analysis on, okay, these are the vulnerabilities that people are reporting to us, right? And then there's the couple that they actually did a call for vulnerabilities, basically like what the industry thinks is up and coming, as opposed to, hey, it's just all based on these statistics from these 4 companies, right? Which was what the initial top 10 for 2017 looked like the proposal, which everybody got up in arms about. So, yeah, definitely Brian brings a good discipline to a lot of things that he does.
Everything.
I know that's one of the reasons that, we all enjoy working with him is he's the adult that makes sure that it all happens, right?
Well, Brian and I work together really well because I am very frenetic and I have a lot of experience with a lot of different things, but Brian is very good at like visualizing things, breaking things down, explaining them to other people. Whereas I am very good at like finding the problems and relaying them back to customers. Brian is very good about explaining the bigger picture, seeing how it ties into things, seeing how it like, this is how your architecture is rendered, etc. So I obviously always love working with Brian. So
yeah. Yeah, and that definitely shows, right? I know we'll talk to him next week about the OWASP SAM project as
talk
well.
about Brian this week.
yeah, we're just going to talk about Brian Glass. Not have him on. That'll be next week. We'll just like sing his praises. But yeah, like the OAuth SAM project, like you talk about stepping back and actually looking at maturity of a program, and putting together a methodology for doing that, right? The the BSIM stuff, but improving that over time is very well thought out. So,
well, Brian and I worked on some of those sorts of things at a government entity that we worked at together as well. So it's very interesting to see not only how Brian has described these things in the public domain, but also seeing how Brian has matured his own maturity models over time, over the like decade that we've been working together. So it's very interesting to see. And you're right. He brings a certain discipline and a certain class to things that the rest of us barbarians just don't have.
Yeah. Well, I get too distracted. I'll be honest, right? Like that's the whole reason I have checklists. It's because if I don't have them, then I don't get everything done that I need to on an assessment. Because Ken and I talk about this at the course all the time is squirrel, right? Like, hey, I like this looks like it could be vulnerable to SQL injection. And all of a sudden you spent like 2 days tracking down something that ultimately wasn't because of some framework nuance, right? So it's having people around like that, like Brian, is a big help to the rest of us to make sure that we do what needs to be done.
The person that I actually learned to appreciate checklists from was someone that Brian and I worked together, J.R. Myers. He's at Denim right now. And he had like this master OneNote that he would have the giant checklist of things that he expected to check. And it really showed me that you can still look for the weird vulnerabilities. You can still try to find that stuff, but you can sort of gloss over the simple stuff first. Yeah. Like, oh, there's no trivial SQL injection. There's no trivial XSS and these sorts of things. All right, I checked that off. Now I can deep dive and come back and look at those sorts of things and actually process like, the sort of weirder vulnerabilities or the sort of weirder things that you would be looking for, Yeah.
So. Yep. So, along those lines, Stefan, right? Like, what is it that you use as your baseline nowadays then? Right? Like what, I know you've got your I'm sure you have your own whatever GitHub instance that has like a list of this is what I need to look at. But are there any resources out there that you point people at if they're asking you?
So like very frequently, if you've taken any of the Go classes that I teach, if you've seen the Go class, like the Go vulnerable Go code, or if you've seen the Kubernetes assessment or whatnot, a lot of it is just based off of those sorts of things. I think what's changed for me over time is I've moved much more towards a programming language theoretic approach to a lot of the security I do. I obviously fit into that LangSec circle. I enjoy LangSec. I enjoy that sort of like semantic based security and whatnot. So I think over time I've moved way more towards that model. Like what are the language features that cause this thing to exist? How do we note these sort of patterns? How do we note this heuristic or this overarching vulnerable pattern here? And so, yeah, there's things that I do for Go code bases that are very specific to Go. And generally, too, I take some of the baselines that I expect, like file system interactions, cryptography interactions, those sorts of things. But I like to see them in a language theoretic slant. I want to look at things as they are reified in Go or as they're reified in JavaScript or Java or those sorts of things, because certain classes of vulnerabilities just won't be the exact same or even the same in other languages.
Yeah.
So,
well, and speaking to this, Ken, specifically, right? Like as far as the framework goes, the checklist that we have for like teaching people how to do code review, it becomes so high level, right? And I think that's what you're talking to, Stefan, is it's like, hey, yeah, we're going to talk about authentication, but depending on the application, depending on the code, authentication in, C looks a lot different than authentication in a Node.js, like an Express.js project, right? It just does. And
also,
there's
your homegrown authentication versus your like library-based authentication or single sign-on based, you have different like Yeah.
Well,
Concerns.
I think the problem is that we, obviously I was a Lisp programmer for many years. So what I'm about to say is going to be painfully Lispy, but every program that you have is effectively some sort of domain specific language that you are creating, even if it's a bunch of function calls that you call every single time that you do authentication, that forms a DSL over the domain of all the functions that you could be calling here. And you can start to analyze your program flows. You can start to analyze your systems in this sort of like DSL specific way, right? And Seth, you and I have talked about this before. Like, do programmers actually even need Turing complete programming languages?
No, but yeah.
But we can get into that another time. But I do think that we don't really take this holistic view of our programs and look at them as like, these are the things these are the patterns we keep doing over and over again. We kind of still play whack-a-mole and look at things like, oh, we're looking at this route and this route's missing this thing, where it's like, well, what's the patterns it should be? What is the DSL that we've described for these sorts of things, et cetera, so.
Yeah. I mean, it a lot of that comes from experience, right? Like when you've looked at so much code, I don't know. I kind of go back to the course again. We start to think about patterns and, DSL as opposed to, hey, what is it that we're trying to do with this specific library, or like, how is this actually implemented? There's authentication patterns and authorization patterns, but applying that, it's hard to teach, right? That's what I'm getting to, right? Is it's very easy to be like, hey, this is what SQL injection looks like in a Flask project. It's pretty easy to identify what that is, as opposed to what is it that you're trying to solve? What is it you're trying to do? What is the pattern? What should that pattern look like? And where does it look like that it's good versus bad? And then identifying that. And that was the other question I was going to ask you. If you started to use, or do you use something like SemGrep for finding those sorts of patterns, or is it still, a one-off regex that you're playing with?
These two fists. No, I mean,
First of all, do you ever think Stefan? Sorry, I'll call you Stefan.
Stefan.
Even with the flair.
You should call me Ishvan. That's it.
Ishvan. Yeah. Okay, Ishvan.
I was going to say, do you think Logi over here has ever relied on just regex?
Yeah.
Just built a simple regex? I don't see that being you.
I am a filthy ripgrep user for a lot of things. I use ripgrep and globs for a lot to get started, but I do think that, so like TrailBits uses SemGrep. Obviously, GitHub has CodeQL. Like there's a lot of things there. So I think SemGrep is fairly interesting. The other thing that R2C, who makes SemGrep, has that I thought was fascinating was there's a library many years ago that Facebook wrote called PFFF, and it was like a abstract library for doing like static analysis on top of like other languages. It was written in OCaml and things like. Did I drop? No. Oh
no,
yeah.
Sorry.
No, you're still on.
You like
trying to get that thing off your face, the banner off your face. Sorry.
Yeah, and then it was just me talking. But it was written in OCaml. It basically allowed you to do analysis, like write an analysis once and then have it run against multiple languages, as long as an AST was representable there. And R2C has revived PFFF as part of their processes there too. So it's interesting to see these sorts of things becoming live again as well. Microsoft obviously has a lot of really interesting things like Wrestler, right? They have the REST API fuzzer that they're working on, but Patrice Godefroy, I think that's how you pronounce his name, has a whole bunch of stuff that he's brought forward, like Dart and Sage and things like that. There's just I think that the space is really set to explode there with a lot of tools. It's just a matter of time.
Yeah. I mean, I've always felt like there's been a disconnect with kind of the general security consulting that's gone on across the board. Like it's very, I mean, I like at this point too, you're doing like red team activities, right? I know that, like, or you're moving into that space, or getting back into it, whatever. Okay. So you're going to be doing red teaming, but
I'm always that guy.
yeah, exactly. But like security consulting space has never lined up very well with what we do on the language side of things, looking for vulnerabilities. Yes, there's some crossover. We'll find a vulnerability, somebody will write an exploit, and then the red team guys take advantage of it. Or when you're doing web app testing, you're looking for specific patterns. You find SQL injection, right? But like trying to marry those two is a difficult problem, because those theoretical vulnerabilities that show up in code don't always have an exploit that goes along with them. And at times it's one of those, like, I don't know how many times you've written a vulnerability that's like, hey, this is bad and could be exploited under certain conditions. And then it never gets fixed because those conditions don't exist right now. Mm-hmm. And even companies accepting risk, right? Like we're using this library that has this CVE that somebody found on the LangSec side of things, but it takes these conditions to exist. So we're just going to keep using it because it's not a problem until it is. Right?
Risk accepted.
Yeah.
It's interesting. There was a paper many years ago called Automatic Exploit Generation. It's a symbolic execution paper. Basically, they wrote a symbolic executor that like generates exploits for a certain class of vulnerability. And super fascinating paper, super interesting stuff. Similar to the Splint paper. Like most people don't know, Splint is a static analyzer for C, but it actually has an abstract interpreter built into it, and it can do a lot of stuff if you wanted to, but we weren't using no one uses it for that. So we're at a place where I think these things can become normalized and we can start to use them much more frequently. But it's also interesting too, like if you look at what Project Zero does, most of Project Zero's bugs are still manual finds.
Yeah.
I think, I don't remember the exact numbers, but it was like the vast majority were manual, and then some class of them were like fuzzing. And then there were like a handful that used more exotic techniques from that. And that was basically it. Most of it was still like two fists and like just knowing what you're doing. So.
Yep.
By the way, have we mentioned what you're doing now?
No, we just jumped straight into it.
I'm the bad guy on the QT. Like we don't drop what I do, Yeah.
Yeah.
If you can find him online.
If I was allowed to announce that.
We keep quiet about these sorts of things. I do quiet operations. So I'm quite professional.
I'll stay quiet then.
No, I mean I do. I'm moving back into an adversary space, which is fairly interesting to me. I'll be working with Ken and a few other friends over at GitHub a little bit, doing some red teaming stuff, and it'll be interesting to see what that space looks like. I'll still be
when you started.
Yeah, I'll still be doing some like research fellowy stuff with Trail of Bits as well, which is nice. Because I can keep my foot in some there. But I like the idea of being adversary sim, at least, seeing where it goes, so it's fun. It'll be fun. It's very interesting to see. But doing OP4, doing long-term red team engagements and whatnot is a fairly interesting space. So
I'm just happy to be working with you again, man.
Yeah, I mean it'll be fun. It's a very interesting space, and I like doing. I've always liked adversary simulation, but I do think I can bring a lot of the interesting parts of what I know to it as well, and see what capabilities we can expand in general. So it'll be fun. Get a few more tattoos out of it and whatnot, and we'll take it from there too. So
yeah, didn't you get some new ones?
Yeah, I got 8 the other day. I got 8 tattoos at once. Yeah.
What?
Yeah.
That's not
some new ones.
Yeah, some new ones. You got 8. How many hours did that take?
It was like 6.5 hours of tattooing. So
that's like not as bad as I thought it would have been. So
yeah,
it must be small tattoos.
Yeah, I have. We have a bunch of new, more visible ones as well. So
my goodness, that's amazing.
Yeah,
that's awesome.
I'm not brave enough to show all of them on camera, since some of them require some of them are like very low on my legs and whatnot. But we can go.
Whoa, whoa, whoa.
You know?
Whoa. I don't want to have to. I don't want to have to go back through and like blur things.
Seriously. Why? It's funny how Logical's episodes always get the E, but this one might get like, an X rating.
yeah. MA. I'm gonna have to we're just gonna blur out the bottom half of the screen on this one.
No one should ever say this podcast is for a mature audience. We should get the immature audience designator.
Yeah, there you go.
But yeah, there's a lot of interesting stuff going on in this space, though, and there's a lot of interesting breaks. But I do think it's fascinating too with what we were thinking about talking about today. Like, yeah. I suspect Tavis found that libgcrypt vuln manually. I mean, I didn't look through the whole process there, but I suspect that was a very manual attack there.
Well, yeah, let's jump into that really quick though, as far as the what that actually was. Like, how much have you looked into that PGP vulnerability and what's going on there?
So I generally recommend clients avoid GPG unless they like absolutely need to. There's a lot of operational security things that you can just get wrong with GPG. There's a lot of crypto modes that you can mess up. When you use it, it's not easy to use. It's not super friendly. There's been tons of attacks around it. But this one was fairly interesting. It's like a heap-based buffer overflow in some of the block sizing for it. So it's like attacking right at the direct level of GPG itself, right? This is not side channel attacks against it. This is not the breaking something that integrates with GPG. It's a direct attack on libgcrypt itself. So
and while you're decrypting something,
right. Which as an adversary, that's exactly the time that you'd want to do it, right? Like, you'd want something that you can attack, weaponize from there, and you could send to an unsuspecting third party that maybe has a public GPG key, such as like a bug bounty team or some incident responders or those sorts of things. You can. It would be very interesting to be able to move from there if you could weaponize that exploit. It's already been fixed. There's already a new version. You should upgrade if you were using that version. And if I recall correctly, it was only used in specific instances of like bleeding edge Ubuntu and Arch, but it did have very interesting impact there because of what it is and how it exploits GPG.
Yeah, I did want to go back to what you said initially, that you felt like it was manual, right? Like the way that we find these bugs. And I know you and I have talked a lot about automation and fuzzing. Like, we should probably talk some more about it because it becomes really interesting. And even some of those bugs that we've found on projects, using fuzz techniques and how that actually, yeah. But anyway. Why do you think that that's the case with this? So in general, why do you think that we as an industry are so tied to the manual techniques as opposed to using automation for finding these bugs? I mean, I know that, you mentioned Project Zero, but I know that some teams rely pretty heavily. At Trail of Bits, when you were there, I know you guys were using some automated techniques to find and identify possible vulnerabilities. So, what is it about manual that we're focusing on so much rather than going to the automated route?
I think we haven't really gotten there, right? So Trail of Bits has a number of tools that help in certain spaces for fuzzing, and folks like Microsoft Research have done a lot of really interesting work in that space, right? With Dart and Sage and those sorts of tools. Yeah. But when you're looking at it from that perspective, right? When you're trying to do abstract interpretation, when you're trying to do symbolic execution for those sorts of things, it really becomes a program analysis problem. Right. Okay. You're trying to understand the flow of a program. You're trying to understand the flow of the system. And then you're trying to also simultaneously find what it should be doing versus what you're able to make it do. Right. And you're trying to derive a lot of information based on just generating things randomly or generating things from a specific set of values. And it's a non-trivial ask. I know Cloudflare is using Mayhem from For All Secure quite heavily. It's a cyber reasoning system. It's very interesting stuff in there, but it's a non-trivial ask to ask teams to like, hey, don't just break software, don't just find vulnerabilities, but start to do program analysis. And oh yeah, by the way, also understand what your program should be doing. Right? Like you can't even ask devs, not a knock against devs, but you can't ask devs like, what is this thing supposed to do? Right?
Mhm.
Like very often they don't know at all. It just, they know what they coded. They don't necessarily know what it's supposed to do. It's a very different ask.
You'd have to start categorizing. Oh, sorry, go ahead.
No, go ahead. Yeah.
No, I was just going to say you kind of have to categorize, like if you think about it, because you mentioned program analysis and like what is the app supposed to do? And one of the reasons I think Brakeman is so successful is that Rails applications are so stringent in exactly how how it's made up, and then also like how the flow goes through. It's a very static. And that doesn't change. Like we know where your routes are. We know once those are defined, it's going to go to these places specifically. Then those places are going to call these places in these ways. And it's very easy to like understand the web app flow. That's one category. Then there's another category of, okay, what does it actually do though from like a business standpoint? What shouldn't it do from a business standpoint is another category. And then like you break it down into like, what's the language it's built on? That's another category. And by the time you get through like all these categories, the way you'd have to customize a tool in order for it to do what a human can do manually, you might as well just done it manually at this point. There's nothing that has like, I've seen that's ever sped up that end-to-end process. Again, Brakeman's been very successful in one category, but like how many times have like, well, I'll just say I've done a lot of Rails analysis, like Rails application analysis, and Brakeman's great for hitting some of the very like, the things that are, you should find, they're kind of low hanging fruit. They're kind of checklist items. Cool. But like, then there's those other categories, and that becomes, again, like even with Brakeman's assistance, you've got this whole other set of things that you have to do. So it's like, yeah, I guess that's my point, is that there's so many categories to tap into that by the time you like automate all that stuff, you've put so much time into customizing your tooling that it's like, what's the point of all that? So,
yeah.
Oh, I was going to say, like, so if you look at Manticore, right, like just to pick on one that I know the code base for, like if you look at Manticore, there's a whole bunch of strategies in there, or Mythex. Mythex is made by Consensus Diligence, Consensus, not Consensus Diligence. Like there are all sorts of scenarios that it can look for, and then it has heuristics to see which states it should prune and which states it should keep, etc. Like someone literally has to sit down and write those sorts of things, and the Mayhem folks have done a lot of work at understanding these sorts of things and coming up with heuristics. And then the Cloudflare folks do a lot of other things on top of that to see how cyber reasoning, like basically you are reasoning about your program when you're doing these sorts of things. You're sitting down and thinking about what your program should do versus what it is doing, and then generating stuff that makes it do one or the other.
Right.
So
I'm not, and I want to be clear, I'm not saying this is impossible. I am saying right now with the current tooling that exists, what you need to do to it to make any of this work, as well as manual analysis, would be, it might as well go back to manual analysis just with what we currently have. That's all I'm saying.
Right. No, but what I mean is like, there's no such thing as a free lunch. Like I think people want a magic tool that you can just point at things. And it's like, no, there's a lot of person hours writing up scenarios, writing up strategies, writing up tooling for these sorts of things. And unless there's some sort of company or group behind it, honestly, it's like, or unless there's some very passionate open source maintainers who are willing to do it regardless of what is occurring in their own lives, like it's not going to just magic up. It takes time and effort to come up with that, which maybe you should focus on doing manually if you're in a company, like.
Well, and like also, we're talking about it in the context of like, okay, maybe from a consultant view where you get like an app and then it connects to some places and whatever, you do your assessment and then you move on. But like, you've seen GitHub in a real production in a company that has many like web-based properties. with a very large scale user base. Like no app that you're looking at is like, okay, here's my app, let me do my assessment, blah 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 blah. Like that's, I think, where the whole like threat modeling and risk assessment kind of stuff comes into plays, because you're talking about, like, you and I have already seen, and you've only been there like a week, and you've already seen that these things connect out to so many places, and there's so many considerations and so many places where security hardening has to happen that isn't just in the app, that it's like, it's not a clean cut, like here's an app and we do an assessment. It's like everything is tangled together, and we have to think about where in these various bits what security issues could arise beyond just the regular web app security type stuff we think of. So,
well, I mean, this is something Seth and I have talked about a lot too. Like Seth has Sputter, which is basically a generative fuzzer, like that knows some things about the character encodings that you have going on. And even with that, it's like, we know roughly what we should be accepting, sort of, maybe. There's a whole bunch of ed cases, and we find things even at that level, like still tactical level. We still find it. And then of course, when you get to the intra-system level, when you get to the large level, you're going to end up with all sorts of breaks and all sorts of problems there, So
yeah.
Well, I mean, the reason I asked the question is because I harken back to my college days doing a course on software testing, right? And talking about QA testing and automation and proving whether and just a single function is doing what you expect it to do and nothing else. And that the problem is super difficult. And based on the fuzz set that you're using, it could be fine, or it could break everything. And so I just have a hard time, as a developer coming into it, thinking, crap, I see so much code that just doesn't have any test cases written, that just doesn't think about anything other than, hey, this is the one case that has to work for me to deploy this application, rather than the flip side where, crap, I need to make sure that nothing else works besides what I expected, right?
Well, I think the other thing is too, when you start to look at program analysis, you're going to run into the sort of Principia Mathematica sort of style of problem, right? Like if you're not familiar with that book or volumes, I should say, the first one is 400 or 500 pages, and all it attempts to do is prove that 1 + 1 is equal to 2. There's obviously a lot of work that goes into that sort of thing. But when you're working with languages, when you're working with systems, there's a lot more proving that goes into it, and you end up in a very different spot. It's very difficult to work with. And I think we're not used to systematically thinking about it. I think what this all belies is that we don't think about any of our systems as formalisms. We think about all of these systems as just systems. They sort of do stuff, and then we come back to them later. We don't really take here's the actual full spec of what this system should be doing.
Yeah. Well, and I don't know, because it's code on top of code on top of code as well. Like you start thinking about something running in, AWS, like a Lambda function, or right? Yes, you've got your small bit that you write, but it's dependent on all of this other code that you probably don't have a lot of, visibility into. And but I always go back to, can I just prove this one function? Can I just prove that this is doing what I expect it to do? And I've never seen a good way to do that as someone that's doing a web development or mobile development or IoT. It's all about just that functionality and exactly what you're saying. We come back to it, it does some stuff, but I've never really proved that out from a program analysis perspective that it is fully secure.
I think there's two things there. The one that's interesting to me is what Tendermint has done. They have a bunch of invariants throughout their code base. They have some preconditions and postconditions, and basically things that should hold regardless. And then their unit tests and their fuzz tests basically exercise these sorts of things. Does this condition always hold as true regardless? So that's sort of Hoare logic or temporal logic that folks do is fairly interesting. But on the flip side, we most of the time don't even have that level of like design by contract knowledge there. If you're not familiar, design by contract is basically this one function should take in, like it requires these conditions, it ensures these conditions, like at the end it should be these, and these things hold regardless of how you execute this function. Most people don't even think about it at that level. Like this function accepts these things and returns these things, and that's it.
Yeah.
I mean, good Lord, JML is what, like 22 years old, right? Like the first published papers on Java modeling language, which is just temporal logic for Java, is from like 1999. We've had these sorts of systems. They're industrial grade. I've ranted about this before on the podcast, and we don't use them, right? Like, and so I don't know how we expect testers to use them if we don't work and design on them for developers to use them either,
Yeah. Well, and it always kind of goes back to that education aspect of like what we're training people to do, not necessarily just like you're saying, security people, but developers in general. There's so much pressure to produce for both of those groups that anything that is anything that goes back to, hey, it doesn't necessarily affect my bottom line from a business perspective is dropped by the wayside. Even if it feels like it's short-sighted or can cause problems in the future, we deal with what's in front of us right now, and we'll deal with that eventually. So part of me understands that, and that goes
if your
back.
business is successful that day, that eventuality does come, and then you're left with a massive amount of technical debt and a bunch of standards that you now have to adhere to, and usually more compliance. And now you're like getting third-party reports about like, oh, you're vulnerable to this and that and the other, and you've had like 17 pen tests each year, and like, or over the years, and you haven't fixed anything.
Yeah,
not a story I've seen or you've seen or Stefan has seen before.
I've never seen any of these sorts of things ever.
No,
but I think the thing is, you can't pen test yourself secure. You can find a whole bunch of things. But you can't fuzz yourself secure either. You can't threat model yourself secure. The only thing you can do is spec yourself secure and then find a whole bunch of bugs in that. Like, you run into some theoretical limits, like Rice's computability theorem and all these sorts of things as you try to go deeper into it, right? So the best you can do is heuristics, and we don't even do those. So
no. Well, we don't.
And that's a good point, because on the heuristics point, there are things I was thinking about when you guys were talking about early on in the podcast, when you're talking about we can give certain things, but we can't give you, like for instance, when Seth and I give training, we can't give, and if we were doing it for devs, it'd be the same thing. We can't give you all the years of experience, but what we could do when you talk about heuristics is like, okay, Seth, you, me, we all know if I've seen like a bunch of like, and or operators, some short circuit statements, and they're all on one line, well, that's a smell. Like we know there's linting tools that's a heuristic you can build upon. There's many little heuristics that just to us who have been doing this and doing code reviews for a long time, like we just know instinctively, oh, that's probably bad. Like, why is there a case statement that's like has 21 entries here? Like, why is this happening? There's clearly some issues with programming, just like, and to dig in deeper, but those are things that are hard to just like pass on to somebody, as the years and years of the little small things that you pick up on. You kind of just know, like, that's a rabbit hole that's worth investigating. Like, take a note.
You mean PMD's cyclomatic complexity complaint is not something that you should ignore? It's not some like meaningless fluff. and it's hard, right? Because you get something that's like the cyclomatic complexity of this is quite large, and then you're like, all right.
What do you do with that? Yeah.
Okay, but also they forgot their authentication checks. So
cool. What's the bigger problem here?
Right. Or what's the more impactful problem? What can I prove during this assessment, or what can I prove during this code review?
Yeah. Well, and that's what it always goes back to is, right? Is there a working exploit? Is there the vulnerability exists? Can you create a working exploit? Because if you can, then it's higher impact and the business will pay attention to it. But again, some of those coding problems, like your cyclability there, like yeah, that's a problem. But to the business right now, that's not the biggest problem. And will it ever be? It ends up on the backlog, which goes back to, do the developers really need a Turing complete language, right? Do they need to be able to do some of that? Because realistically, they need to be able to take some user input and display something back out, right? Like there's a limited set. And like Rails, like these very formal frameworks do a good job of limiting some of that. But they still allow that Turing completeness behind the scenes. Is where we get into a lot of these business logic flaws and other things that we have problems with, right?
Yeah, they definitely allow for a lot of complexity.
Yeah,
and a lot of problems.
Well, the meta programming, right? Like that's another, right? Like with Ruby, that becomes another huge issue, right? The amount of complexity that you can load into any one line. But like, is there
people make the same mistakes with Java too? Yeah, like reflection with Java. Yeah.
But I also think, though, it harkens back to like we were doing a learning class on formal modeling, and one of the things we worked through was like Tamarin. So Tamarin is a prover that focuses on cryptography, and the way that it works is it gives you some ideal, like if you say I need to use AES in this mode, it gives you an idealized AES implementation. So obviously, there can be all sorts of bugs in your AES implementation, but if you wire things together incorrectly, you use AES CBC without some sort of HMAC, for example, there's all sorts of tampering risks there. And we need to move things to the level that actual developers work at, rather than moving them to the level that maybe like an implementation detail or whatnot, right? And we don't do that very frequently for our security tools. Most of the time, it's very low level. You have this character, which causes this problem, which does this thing, rather than, oh, hey, you're using the entire wrong processing system for this. It's very whack-a-mole still, even how we describe things back to developers.
Yeah. I don't know, like I'm hearkening back to this discussion that Ken and I had with Manico, right? Like about the one true framework, as I like to call it, right? Like, oh, at some point we're going to have this great framework that, eliminates all classes of vulnerabilities, or, most. And while I agree, there's always those edge cases that developers come up with where they feel like they need more power. They need the ability to execute some query in a different way, so they need raw access to the database, right? Like they bypass security rails in order to accomplish their task. And so where does that fall down from developing a framework perspective, from developing these tools perspective, that, hey, we haven't given them we haven't given them everything that we need. And I don't know if that just goes back to like the whole contract idea, like the whole description idea of, hey, this has been formally defined enough that we give you the tools that are necessary to implement your code.
I honestly think that at some point, so it's like Greenspun's 10th rule, right? I don't know if you've ever heard of this, or you probably heard of it, but it was like 20 years ago. It's like any large C or Fortran program is a half-baked, bug-ridden, like slow implementation of half of Common Lisp. But whenever you have large programs, you literally are designing a framework, you're designing a language, like a DSL that you use. And I think we're not, the problem is we do these things, we understand them intrinsically, but we don't process and analyze systems at this level either. We just look at them at a very tactical level, even if the vulnerabilities are at a much higher level or something else they should be doing.
Okay.
You know what I'm saying? So
yeah.
It's I think a one true framework is not possible, but I do think one true framework within an organization is possible. I've seen it. There was a large hedge fund that several folks who've been on Absolute AppSec have worked on, and they had this framework. And every application, if you wanted to deviate from any single thing that they had, like security had blessed, you had to get an exception. And it was on the flip side, security would respond to this sorts of things like, oh, I need an escape hatch. And they would sit down and like, okay, let me understand your problem set. Let me sit down and see, okay, we can design this securely in this way. And maybe it's not as secure as the rest of the system, but we can add it so that from now on, you do the standard thing for you, right? And but here's the thing, that costs money, that costs time, that costs people thinking about things. And, it also still, after many years, people were like, yeah, but it's not the cool thing, so we don't want to do this anymore.
Yeah, I was going to say, I don't know how long-term that would work. It would cause a lot of friction, and, you're taking away people's, like for engineers, I like to think of them as creative people, and I think you're taking away some of that creativity, and that freedom of choice. And I think it's not really a practical long-term option, honestly. But, I don't think I don't even think a framework can 100% solve even like a perfect framework, because you just have, I'll give you for instance, I think it was maybe last week or the week before, I was reviewing a pretty large size PR, and, individually, all the bits made a lot of sense. They all made a lot of sense, and everything looked right. And, I kind of had to take a step back and talk to another team, actually 2 other team members, about the context of the application. And we started, thinking about it. We all, reviewed all the code. Like I said, it all looked pretty good. We hopped off the call, something didn't sit right. And I went back and realized, oh, wow, like we haven't actually, it's difficult to think about and reason about, but there is actually an authorization bypass there. And here's why. And we had 3 very talented people looking at this, and very experienced people. And again, looking at it, it all looked right. There was no one specific thing, like a method being called insecurely or anything like that. It was just a weird little, you had to connect a dot that you could maybe do this thing, then that thing. And then, oh no, we now have an authorization bypass. It was non-trivial for sure. So my point being that even if you had a perfect framework and you had 100% adoption within your organization, and nobody complained that, they're limiting their creativity, and that also the upkeep on that framework.
Oh,
and
yeah.
Also, again, this is one of the things that we criticize, is that if you build things internally and it's not open source, or it's not built upon something that gets the whole world looking at it, you then have some level of obscurity, and you have less eyes on the software to then potentially find issues that you thought were secure. But on top of all of that, you also may just have a situation where everything's developed right, you think, except for there's some complexity that ends up being some weird authorization bypass or logic flaw or whatever you want to call it. So it's a hard one. For sure.
It's hard too, because we don't. So honestly, the thing that you should focus on is, if you're going to do that deep formal specification, it should be on the framework side. So very often when you read the papers on these things, if you read the W7 paper or something like that, that you want to prove a security kernel. You want to have some small portion of your code base that is formally defined, very well tested, and then the things that developers build on from there is a little bit less formally tested, a little bit less trusted, and then from there you can sort of play whack-a-mole with things. But at least your security kernel is known to be good, is secure, has those sorts of things built into it. That's where you would focus your efforts if you're doing these sorts of higher level testing, right? That's where you would do the formal specification, the design by contract, those sorts of things, so that you had some assurance about your security kernel, your authentication system, your authorization system, those sorts of things. And then you would move everything else out to developer code. But to your point, Ken, some of those can become very, very rigid. If you use macaroons, right, hash-based unforgeable references, right? In object capability systems, OCAP systems can have formal proofs. They can have all sorts of things there, but they're also a little more exotic. They're a little different from what most people are used to thinking about. They also require a very specific style of thought. I now have to bless this reference, and this reference is an unforgeable reference, and I pass this back to a user, and the user could be some entity or anything in there. And it's a very different style of programming and a very different style of thinking about design, which we don't do very frequently, you know?
Have you messed at all with what is it called, Seth? The one we were talking about, component oriented web frameworks?
Yes. Yeah. Ken, you and I were talking about that when you were looking at like Apache Wicked or whatever there.
Yes. Yeah. I've been trying to do some research there, trying to figure out how to, because it's really weird. Like you in some ways immediately kill off like a whole class of vulnerabilities like CSRF and realistically, even to some degree authorization flaws, because you have to have gone somewhere you were authorized to go for you to now reach the next place you want to go, because it's all based off of stateful tracking. So I couldn't just go to some URL that I wasn't told to go to, because again, if I do, my state doesn't match up and I get a big middle finger from the framework. Mm-hmm. And so I think it's pretty interesting to see there are ways that, like, talking again about categories of like a web app, like the framework level, language level, behavior level, whatever it is, like this is definitely one of those things where the framework itself is killing off whole classes of vulns, I think. Again, still early in the stages of research there, but it's just also, can I go back to what you were saying? I wanted to like make sure I understood that right. Are you, to summarize for the layman, are you saying you draft a requirement, you essentially have requirements and you build off those, you build off the requirements and then make sure that your specifications, like, I'm not sure if you're using tooling or if you're just saying build your app according to these requirements and then do a review of those requirements? Like, I guess that's the connection there that I was trying to figure out, is like,
Are you asking about formal specification, Ken?
Yes, like how in a practical sense do I get started with that, is what I'm trying to say, I guess. My back hurts. So I can see maybe the wheels are spinning there. I don't know.
I mean, I was just going to let Seth answer first.
I was specifically wondering from your standpoint, like when it comes to these requirements, how do you build for those requirements? Like, I'm assuming that's what you're saying when you're building according to specifications. Like, I honestly I'm not, familiar how that would look, I guess.
Seth, if you want to start, man. Yeah, I was trying to figure out if there was a good like resource that we could drop up there for people that are unfamiliar with it.
Well, I think probably the easiest layman's term is if you were familiar with BDD frameworks like Qux.
Yeah,
probably the easiest way for normal folks to get started with specification. Like, and I know BDD was a fad and it came and kind of went, and some people still do it. It's super useful, but specifications or test-driven design is sort of an informal specification system, right? So what if you think about BDD, you're like, like the system.
You're testing for what it should do. Yeah,
exactly. Right. So what specification is basically saying is, I expect the system to do exactly this. It will use these components. It will do these things in this way, in this order. And then it restricts down the program domain that you have to look through as you're testing. So why it's interesting to Seth and I and other security researchers is that, when you look at if you think about a program as a graph, you can give it an input, a string, an integer, whatever it is, and it does this thing. And if you give it another integer and it does this other thing, right? If you graph that out as a set of states, right, you're actually restricting down the range of your function there. So let's say if you take all integers, there's negative infinity all the way to infinity. But if you say, actually, the only states we care about are 0 to 10, and our program will only run if you have an integer between 0 and 10, that's the specification level that we're getting there, right? Mm-hmm. That's the sort of thing that you restrict down, and now you only have 10 states to test rather than an infinite number of states to test. Does that make sense?
Yeah, it does. There's a certain style of programming.
It
requires you to scope. Oh, go ahead.
Yeah, it just forces you to be extremely disciplined as well, right? Because there's none of this like I don't know what I'm getting. It's to have a formal specification, every possible input that's coming into a function and then what the output should look like, right? Like if you don't, then you can't define what that state's going to look like.
There's a super interesting programming language made by Bertrand Meyer called Eiffel. And Eiffel took some of the things that we learned from Algol and some of the things that we learned from Ada and some of the things that Bertrand Meyer did for testing, right? And Bertrand Meyer was also the person who coined the phrase design by contract, if I recall correctly. And it's basically baking Hoare logic or like preconditions and postconditions into your programming language. But what it became called was bondage and discipline programming because it forced you to be so strict and you got punished by the compiler if you weren't strict there. So it very quickly became a trope like, oh, this is difficult, painful types of programming that no one wants to do. Or even think about Haskell, right? Think about those sorts of like newer, more exotic functional languages. Haskell was always seen as like, oh, you fight with the compiler, and once you're done fighting with the compiler, then your program works. Whereas people aren't really thinking like the compiler is sort of a prover that tells me some information about my program, and I can figure out if that's useful to me. And then I go back and forth and iterate quickly with the compiler as a tool. So it's honestly a mindset view that is now coming to the fore, even though it's been around forever, right? None of this is new. So, I mean,
yeah, I feel like I'm like trying to Google because I feel like I've heard arguments for and against building functions that only do one thing, and all of your code is built in such a way. And I cannot for the life of me recall what the pros and the cons. Well, I mean, we're talking about the pros, but I know there were cons, and I don't remember what they were because like I'm trying to go into my memory from books I've read. But I know that there are arguments both for and against like having such simple functions. I just can't remember what they are.
It's the old quip, I think from Tony Hoare, is that you can write code such that there are no obvious bugs. Or you can write code so simply such that there are obviously no bugs, right? But writing code that simply means that you very often may have a very simple function, and then you call that function 10 times in a code base when you maybe could just remove 5 of those calls to that very simple function if you just duplicated the code and made one function a little more complex. So it's like understanding the point in which
taking variable
code, right. There's an efficiency loss with a lot of these sorts of things, right? There's a reason why there's a compiler for C called CompCert. CompCert basically does it's like a more secure, verifiable build of C, but it doesn't do a lot of the optimizations. It does not do a lot of the basically the UB optimizations that you see in Clang and GCC because they can't be formally verified. So therefore, CompCert does not get you there, and you lose all these sorts of things once you try to use a system that does these sorts of things for you, like inlining, right? Inlining is non-trivial. If you look at how OCaml inlines, there's some weird heuristic like if there's 30 operations in there, you can inline it. Otherwise, don't inline. And it's like, well, that's not super. Like there are. If you look at the OCaml verification papers, they go towards inlining, like the inlining heuristics for a reason, So it's a weird space. It's hard to do, and there's a lot of interesting stuff. And I think we're just now getting to the point where people realize that these are practically applicable. But you're right, Ken. There are trade-offs for all of these sorts of things. But I often wonder, like, do we actually want things to be faster all the time? Like maybe sometimes we should be okay with it being 10% slower if it's more secure.
Well, and that was going to be my next point is we have this trade-off like for years and years, and especially like that speed is the end all be all, right? And I feel like we're finally getting to that point that there is a little bit of trade-off, especially when we get to the compiler level, that security now is more important. So it's okay for us to be, 5%, 10% slower as long as we have provided some sort of formal specification, as long as we can prove that, the input is secure, like we're going to actually do some of that where we didn't before because we just couldn't handle it. Right. It goes back to the times of like rollout of HTTPS, right? Secure traffic. Like for years, we didn't encrypt things because it took too long to encrypt things, right?
Right.
And once it became usable, that we didn't notice it as humans, then we started to do it all over the place.
Yeah, and also a lot of those arguments were based on things at the time and hardware. So, like, remember, we're all old enough to remember Hyphen. Remember Hyphen, the crypto accelerator card that you could plug into PCI and it would into a PCI slot, not PCI process, as in payment card industry, but like a PCI bus, and it would do all these crypto operations for you. And it's like, nowadays we have like AES in CPUs. Like many CPUs have AES. They might have SHA-1 or they might have some other hashing algorithms built into them. And it's like, we're in a very different landscape than we were previously. I also posted in chat here, I posted some stuff to object capability, but there's also a programming language called E. It's a distributed object capabilities programming language. And it has some interesting restrictions, but it's based on the model that you're talking about there, Ken, where you like in order to go to this thing, you have to have previously known it at all. And these things are not guessable. There's some sort of hash specification for it, etc. And that's what E is based on. Now, there's other versions of E called Monty and others, but this sort of system has been around for a long time. We've known that they break down confused deputy problems such as clickjacking, such as CSRF, and those sorts of things. But we haven't used them because they're a little more exotic. They're a little different. E as a programming language looks a little like, it has some Pascalisms and whatnot, But we've had all the answers to these, like Eros and LLNL and all those operating systems. They've been around since the late 60s, early 70s. We know how to fix these things. We just don't. So
what's funny is it's also not, I have found more often than not, it's not even a conversation of like, when it comes to like, do we want to worry about computational performance and response time and all that, or do we want to worry more about building some new features that our clients are asking for? It's usually not. I don't think it's usually a question of like, well, we can give a trade-off for security. It will be more secure, but it'll be slower. Usually it's like, well, it'll be a little bit slower, but we'll get those features knocked out that those customers have been asking for and said they're going to buy 1,000 licenses, for this product. So that's what we are more concerned about. I just don't usually ever see anybody put any thought into, unless it's like you guys mentioned encryption and hashing. Yeah, that's one that they're. You know what cracks me up about that is that anytime that conversation happens, like, or oftentimes when you have discussions with developers, like, it always seems to go to crypto, and it always seems to go to computational speed and performance issues with crypto. And like, it just cracks me up because like I've watched engineers have conversations and debates at length about cryptography and then go and write like insecure direct object reference the next day. And it's just like, yeah, we can get fancy, but we still have these stupid fucking problems that we have to solve. And it's like,
Well, and crypto is one of those things too that I learned with Paul Kerr. He was the head of crypto at Trail of Bits, and now he's over at Oracle. Paul was on the podcast once before as well, but I learned a ton of stuff just from that, like just working around crypto and things like that. And it's very funny though, because you see these exotic systems, right? Like we've seen like oblivious pseudo-random function login systems, or opaque. Basically a way of building password authenticated key exchanges. Opaque is a new system for that. So I've seen all these sorts of things, and then you're looking at the code and it like writes the key to the file system as 777.
Exactly.
We have all the math, but then it's like, wait, but anyone who has access to the server can change the key.
Yeah, we have the technical solutions to a lot of these problems. It's just it's the humans.
Personally, I think the problem or the real problem that belies this is that in the year of our Lord 2021, we're still deploying Linux and FreeBSD servers to do stuff, but now we deploy them into the cloud. Whereas I'm not trying to say we should all use a pass or anything like that, but I do think something like Mirage or something like any of these sorts of like exakernel style systems would be way better for security, because we shouldn't be thinking about server security. It's ridiculous that we're still deploying servers in 2021.
Well, okay, so that again, that goes back to the whole like Turing complete, right? Do you really need a full operating system to do any of this? No, you really don't, right? Like there's other things that are out there that are probably a better solution, but it's just where we're at.
Yeah, Mirage is super fascinating. If you haven't seen it, I'll post it into chat here. But Mirage is an OCaml framework for basically making Zen VMs. So basically, you write some code, it compiles around it, and then you get out a binary that you can run in Zen, and you can say whether or not you need a TCP/IP stack. You can say whether or not you need to have a file system attached to it. Right? If you have a web app that literally just processes some data and sends it back, you don't need to have file system access there. So just remove it. Right? Yeah. But and that's what you get with things like gvisor, binctr. All of these things are ways of handling this that we just don't like. We're not using nearly as much as we could be. We shouldn't be deploying containers. We shouldn't be.
We lost him.
Uh-oh.
I'm going to post that link for Mirage. Oh, you already did there. And I'll post it in our general Slack as well.
That was weird. I don't know why, but I just got bumped. StreamYard just refreshed me, but whatever. Like we really don't need to have these sorts of things there. Also, to Derek asking about the singleton pattern. I think there's a very funny comment by Runner Olafsson. One of the he does functional Scala. He wrote the book Functional Programming in Scala. He has a very funny quip where he's like, the gang of four is wrong. You don't use any of those patterns, but the only pattern you do use is the interpreter pattern. That one is used everywhere. Like everything is the interpreter pattern if you look at it long enough. But I don't think that there are like security patterns that are done very frequently. We haven't done that level of analysis even to what the gang of four has done. Although I think the LangSec folks do look at those sorts of things. Everything is an interpreter. Everything is a parser. Those sorts of discussions. Everything is a language described over it. But we really haven't done that level of like pattern analysis there to really understand things at that level. You know, there's not going to be like an absolute AppSec of 4 style pattern book that we release. That's like
what? I thought we were working on that.
No. You know, well, I'm sorry to say it, but it's very difficult because like authorization is unless you release something like SAML and your pattern is SAML, use SAML and make sure it's applied, or use object capability models and applied. It's very difficult to say like, here's an authorization model that makes sense for everyone.
Oh yeah. Yep. It just doesn't. Yeah. It doesn't fit quite in the same way. So you're right. Well, gentlemen, we've been going for a good hour, and all with winging it, as you like to say.
I love to wing it. I mean, that's the whole point. And what's funny is it all comes back to PGP being problematic.
Oh, it is. And I knew we were going to get there somehow, right? But yeah, and I know that we could continue on and on, right? Like, but I don't know if there's a way for us to really put a bow on it today, as far as pointing people at something that would help them either get into formal specification, or at least like test-driven development, BDD, right? Like that kind of stuff could be helpful. But what do you think?
I think hypothesis is probably the best thing that folks can start to look at. So hypothesis is basically a property testing framework, right? It's similar to Quick Check if you've ever seen that in Haskell, or if you've seen that in other programming languages. But hypothesis is basically you write unit test looking items, and then hypothesis runs a fuzzer to see if it can find something that invalidates your assumptions there. You also can use like libfuzzer. Libfuzzer is super good. GoFuzz. Both the Google one and the non-Google one, depending on hyphen, I never remember which one is which, but basically GoFuzz and whatnot are there. But for Go, there's also Gopter. I think looking at these sorts of things, understanding your program from that level, and actually driving specifications, even at a simple, like, this is what we expect it to do versus what it is doing, that's super huge. And that's where you would tie into like libgcrypt and whatnot there. So,
yeah,
like if you were fuzzing this sort of thing, Bobby Tonic, who's been on the podcast before, when we were talking about the Kubernetes work, when he and I would work together, one of the things he would always do is like, all right, let me find some GoFuzz tests that I can write. Let me find some properties that I can invalidate, and I'm going to write a fuzzer that tries to break the format here of it. And just go from there. I'm going to start with some simple, like, first principles sort of things and go from there.
Yeah. Well, and I mean, that's the thing is, like, I go back to kind of the manual / automated approach, right? And technically this is what we do when we're doing a web app test and we're using something like Burp Suite. Mm-hmm. It's like, I always end up falling back to using the fuzzing tools that are built into that, right? Once I understand kind of the structure of a request and a response, like doing the same thing if we're analyzing, libgpg or something else, makes a lot of sense. But it does require you to put some time into it as well. Copy those. Yeah,
it's also fascinating because like Microsoft has released Wrestler, and there's a few other systems that they've released recently. But basically, there are these sorts of frameworks that are out there for building like an actual program analysis focused approach to security testing as well. I also wrote I had a riff based on what I was thinking once. Where it was like, in security, very frequently we try to find where there's a gap, or we try to find a bug, but we're never like, hey, I use Sputter to generate all of these things, and these are all the test cases that passed. These are all the things that you expected it to do, and then here's a list of things that are actually broken. We always just give them the broken, and then we never talk about the larger program. Like, should these things even be occurring to begin with anyway? We don't know. Because we have no way of describing that or relaying that back to customers or teams or anything there. So it's a very fascinating space that we could be doing a lot more with,
Yep. Yeah. And I think we'll get there, right? Well, good. Okay. So yeah, we have to get there. And we will, right? Like, it's just we're closer now than we ever have been, at least in my experience in the industry, right? Like we keep pushing, like new tools come out, new techniques, and like all these different capabilities that exist out there. You may as well start using them to see how it applies.
Yeah, the last one I would post there is that last link that I shared, which is the Microsoft REST API fuzz testing. They have a whole system. It's written in F#, so of course I would be interested in it. But it basically wraps a lot of these sorts of things, so you can do multiple strategies to attack your app from there. So yeah, fairly fascinating.
Cool. Yeah, we'll take a look at those if you're interested. Otherwise, you can find us online. We will post Logi's Twitter address, or jump into Absolute AppSec Slack if you want to continue the conversation. But we will have Stefan back on at some point, I'm sure, right? To talk even more. I think we're going to start doing regular check-ins with Stefan on stuff.
Yes. So he's just finding out about it right now.
Yeah.
I mean, that's fine. I'm always happy to come on and talk. You know me. I'm not someone who is shy about talking.
We hadn't noticed there. Well, good. Ken, anything else to wrap up today?
Nope. I just got to get going. So thank you so much, guys. And those watching the stream.
Okay. All right. We'll catch everybody next week. Join us then.
Thanks, everyone.
Later.